Okay, this is notes 3-3, linear programming. Okay, on these, we're going to start kind of looking at graphs that we can use in the business world to make business decisions. We're going to find our maximum and minimum values for different products. So as we move on, it'll make a lot more sense on where the constraints are coming from as far as finding our maximum and minimum. Now, the constraints are what you see on the side on number 1 there, where it says x is greater than 0 or equal to, and y is greater than or equal to 0, and x plus y is less than or equal to 6. Those are the restrictions or constraints on the graph. Those are the what we have to use in order to eliminate part of the graph, which will make sense in a second. So it's building on the N3-2 that we did. Okay, so first thing we want to do is we're going to go ahead and label these guys A, B, and C so we can keep them straight as we go. So this will be A, B, C. Okay, now we want to go over to the graph and graph those. First one that I'm going to graph is x is greater than or equal to 0. So we know that our x-axis is the one on the bottom. This is my x-axis. Okay, greater than means that it is up, so anything above this line. So anything above this line would work. The next one says that y is, so this is A, sorry. Now B is our y-axis, So this is going to be equation B. Y is greater than or equal to 0. So that's anything that direction. So pretty much anything on the graph that's given would work right now. Now the final one will be that x plus y has to be less than or equal to 6. That's the one that will show us our area where it blocks it off. Okay, so in order to graph that, we're going to use our x and y intercepts that we've already done. Okay, so in order to be a y-intercept, my x value must be 0. In order for it to be an x-intercept, my y value must be 0. So if I plug 0 in for x, then y is 6. If I plug 0 in for y, x is 6. So I can go up on my graph, 1, 2, 3, 4, 5, 6, put a point. Okay, same thing, over 6 up 0, 1, 2, 3, 4, 5, 6, put a point. That is my graph. It is equal to, so it is less than or equal to, so it's a solid line. Okay, and less than would be below it. So see how the x went up and y went to the right. This one is going down. So if I were shading, these would have been shaded up. This would have been shaded over, and this one is shaded down. So I see that I now have my triple shaded area, and it is made up by 3 different points. Okay, we know 2 of our points because we just did them, and our other one will be our origin, this one here. Okay, so I make my corners, my table, corners. Okay, on my corners I have 0, 0, and then the 2 that I have, which is over 0 up 6, and over 6 up 0. I'm going to plug them back into my original equation, the constraint equation, which is 4x plus 5y. And that's going to give me equal what my constraints are. Okay? So on the first one, 4, plug in the x value, which is 0, plus 5, plug in my y value, which is 0, and that equals 4 times 0 is 0, 5 times 0 is 0, so that equals 0. Second one, 4 times my x value, which is 0, plus 5 times my y value, which is 6, equals, so 4 times 0 is 0, 5 times 6 is 30. And the last one, 4 times x, which is 6, plus 5 times y, which is 0. 4 times 6 is 24. 5 times 0 is 0. So this is 24. So now I have all of my numbers accounted for the different regions. So the minimum value of C, the smallest I had, equaled out to 0. And that happened when my X value was 0 and my Y value was 0. The maximum value of C was 30, and that happened when my X was 0 and my Y was 6. Okay. Moving on to number 2. Same thing. We have our different graphs here. The first one is saying X is greater than or equal to 2. So I'm going to go on my X-axis. 1, 2. And it's a solid line. So I'm drawing a solid line going through 2. Okay. My next one says X is less than or equal to 5. So 3, 4, 5. All right, then it says my Y is greater than 1. So 1 is right here, or equal to. So I'm making a flat line at 1. And it says Y is less than or equal to 6. 1, 2, I'm sorry, that's 2, 3, 4, 5, 6. Okay, so here's my corners. And now let's go back and look at those one more time. We said X was greater than 2. Okay, so that means on our X that we drew this line here, it's greater than it, so that's to the right. And it said that it was less than or equal to 5. X is less than 5, so I shade this way. I can already see they're overlapping. There's no reason to go above or below because my Y is going to be greater than 1, so that's up, and less than 6. So I see that all of my action is in here. These are my constrained areas. Okay, so the coordinates of those are, for this first one that was over 2 up 1, the top one was over 2 up 6, stand with the top, the other corner was over 5 up 6. And the bottom one was over 5 up 1. Okay, I'm going to use those guys to build my corners, my table again. And my original equation, which is 3x plus 4y equals C. Okay, my corners are 2, 1. Just label them out, doesn't matter the order. 5, 1, 5, 6, and 2, 6. First one, that's 3 times my x, which is 2, plus 4 times my y, which is 1, equals 3 times 2 is 6, plus 4 times 1, which is 4, that would be 10. And the second one, 3 times 5, plus 4 times 1 again. That's 3 times 5 is 15. 4 times 1 is 4. 15 plus 4 is 19. Next one, 3 times my x, which is 5, plus 4 times my y, which is 6, equals 3 times 5 is 15. 4 times 6 is 24. When I add those together, that is 39. And lastly, I've got 3 times 2 for x, plus 4 times 6 for y. 3 times 2 is 6, plus 4 times 6 is 24, so that is a total of 30. So we go back to it. Now we look at those numbers we just created. The minimum value, the smallest I had, was 10, and that occurred when x was 2. Let me zoom out some more. And y was 1. The maximum value, which was 39, that occurred when x was, let's write that in, 39. That occurred when x was 5 and y is 6. Okay? Okay, number 3. Okay, number 3, let me go ahead and zoom out a little bit. Number 3 has the constraints or restrictions of x is greater than or equal to 0. So that means that it is anything above x. Okay, y is greater than or equal to 0, so anything this direction. That's where my y's are greater. And then I have to use, find my zeros, or find my x, y intercept. So I'm going to plug in for the first one. I'm going to plug in 0 for x and get y. Then I'll plug in, let me zoom in a little bit. I'll plug in 0 for y and get my x value. Okay, so if I do that, I plug in 0 for x, that's 4 times 0, which is 0, then 3y. So on this first one, that would be 3y is, 3y in this case is greater than or equal to 24, divided by 3. So y would equal 8. If I plug 0 in for y, so that would be 3 times 0 is 0, so 4x is greater than or equal to 24. So if I divided both sides by 4, that would give me 6. Okay, I do the same thing for the next one. Plug 0 in for x, and then 0 in for y. Solve for the opposite. So if I plug 0 in for x, that leaves me 3y equals 15. Divide by 3, that would give me 5. If I plug 0 in for y, that's 3 times y, so 3 times 0 is 0, and then x would equal 15. Okay, now if I go and I graph these guys, so let me zoom out. I graph that first one. And the first one is over 0, up 8, put a point. So 1, 2, 3, 4, 5, 6, 7, 8, put a point. And then it's over 6, up 0. 1, 2, 3, 4, 5, 6, put a point. And those guys are equal to as well, so it's a straight line. And it says it has to be greater than this one, so it's above it. So everything in this area here is no good, no good. Okay, next one, over 0, up 5, 1, 2, 3, 4, 5, put a point. Over 15, so there's 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, put a point. And this is equal to as well. Okay, so, and it says greater than it. So far, it's everything greater than the x, greater than the y, greater than the first line we graphed, and greater than the second line. So this will actually be our triple shaded area. Actually, quadruple shaded area. So I need this point here. We already have the other ones, the 3 that make the enclosure, which was 15, 0. We have 1, 2, 3, 4, 5. So 0, 5, I'm sorry. We have 8 over 0, up 8 is this one. And then we actually have to find the one, the intersection. Okay, a couple of ways. We could put them in y equals and solve, or we could use either of our methods, elimination or substitution. I would recommend putting them in y equals form, put them in your calculator, graph them, and find that middle point. This middle point is actually, I'm going to go ahead and give it to you. It is an x value of 3 and a y value of 4. So this point is 3, 4. So now I have my 3 corners. So the first, let me zoom in. Right in my corners. And my equation, 6x plus 7y equals c. My corners being 0, 8, 3, 4, and 15, 0. Okay, if I plug 0 in on the first one, that'd be 6 times 0 is 0. And then 7 times 8 is 56, so that's 6 times 0 plus 7 times 8 equals 56. And our second one, that's 6 times 3 plus 7 times 4. That comes out to a total of 46. And finally, 6 times 15 plus 7 times 0. That comes out to a total of 90. I can clearly see my minimum is 46. It looks like my maximum is 90. However, let's go back and zoom out. Our minimum value, most definitely, is 46. And that happened when x was 3 and y is 4. The maximum value, though, does not exist here, okay, because see how our graph, there is no enclosure out around these areas, okay? It just keeps on going forever. So this graph has no maximum. So let me zoom in. No max. Okay, this concludes the notes for 3.3.